Hello, grade 12s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abudiwa Sos Gobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have question 2. It says A to F in the table below represents 6 organic compounds. Now we know the strategy is that we will try to identify the homologous series to which each and every organic compound here belongs. Now, starting with A, we can see the OH, so we know that this belongs in the alcohol homologous series. Then in B, we have pentan 3-one, which tells us that this belongs in the ketone homologous series. In C, we have methyl butanoate, which tells us that this belongs in the ester homologous series, since it is made out of 2 homologous series, the alcohol and the carboxylic acid. Then D, looking at the functional group here, who can see that this is a carboxyl group, so this belongs in carboxylic acid homologous series. And then let's have a look at this one. We can see that the double bond oxygen is in between other carbon atoms. So this again is a ketone, right? And then we have F here. Looking at this here, we can see that obviously this one has to be an alkane, the single bonds between the carbon atoms, right? Then 2.1.1 says, is it a primary, secondary, or tertiary alcohol? Give a reason for the answer. So we are considering compound A. Is it a primary, secondary, or tertiary? Let's locate the carbon with the OH, and then let's see how many other carbons is it bonded to. You can see that it is bonded to this carbon here. So the first thing that we do is locate the carbon with the hydroxyl group and then check how many other carbon atoms is it bonded to. So it's bonded to this carbon atom, it's bonded to that, and then it's bonded to this. So once we see a methyl branch, we know that we will create a tertiary alcohol. So this is supposed to be tertiary. And the reason for that is simply the carbon with the hydroxyl group. So the carbon with the hydroxyl group is bonded to 3 other carbon atoms. And just like that, you have your 2 marks. Then 2.1.2 says, write down the IUPAC name for the above mentioned compound. Now, what is the IUPAC name of compound A? We're going to start numbering from the side where we see the closest disturbance. So that's 1, 2, 3, and then 4, right? So in number 2, that's where we have a methyl branch and then the hydroxyl group. So this is supposed to be 2-methyl. And then what do we see? We can see that in number 2, we have the hydroxyl group, but then we have 4 here. So this is supposed to be butan 2-ol, right? So butan 2-methyl butan 2-ol. Then 2.1.3. So this was for 2.1.2. 2.1.3 says the above mentioned compound undergoes an elimination reaction. Write down the structural formula of the major product that is formed. Write down the what? Structural formula, right? So if this undergoes elimination reaction, we know that the OH and the hydrogen will be eliminated, which will make a double bond here in the first carbon. So our structural formula for 2.1.3 should look like this. This is 1, 2, 3, 4. And then we will have our double bond here between the first and the second carbon, because that's where we took the OH and the hydrogen. But then here we still have our branch, our methyl branch. So it goes like that. And then here we'll be left with 2 hydrogen atoms since we'll be taking a hydrogen from here. But then remember, we no longer have the OH here. Then let's fill in our hydrogens like that. And then our hydrogens, our hydrogens, our hydrogens. So the structure that we should have is more or less like this, right? So it is supposed to be like that. And then that's what, that's 2-methyl but1-ene, right? So if you were to give the IUPAC name, but then they're not looking for the IUPAC name. Then let's proceed to 2.2. It says, consider the organic compound B, define the term functional isomer. So 2.2.1, what is a functional isomer? So we say functional isomer is an organic compound that has the same molecular formula, not general, same molecular formula, but different functional group. But then different functional group, right? So for 2 marks, that's how you are supposed to define functional isomer. It's an organic compound that is the same molecular formula, but different functional group. Then write down 2.2.2, the homologous series to which the above mentioned compound belongs, right? So we've already identified that B belongs where? In the ketone homologous series. Now, IUPAC name of its functional isomer, we know that the functional isomer to a ketone is an aldehyde. Now, if we have pentan 3 on, an aldehyde should only just be pentanal. Remember, there is no indication of the functional group when it comes to aldehyde, because with an aldehyde, the functional group will always be on the first carbon. So that's pentanal. And then 2.2.4, letter that represents its positional isomer. So because we have identified that this is a ketone and also this one is a ketone, we know that for positional isomers, we should identify compounds that belong in the same homologous series. So without even confirming here, we can rest assured that the answer is definitely E, right? And then if you want to confirm, let's count the number of carbon atoms. That's 1, 2, 3, 4, 5. And then looking at pentan, we can see that also this one is 5. It has 5 carbon atoms. So definitely it is the positional isomer, because this one we can see that we can see that when considering this one, the carbonyl group is now in the second carbon, but then here the carbonyl group was in the third carbon. So positional isomer, remember, same molecular formula, but different positions of the functional group. Here it was in position 2, and then here it is in position 3. Okay, so 2.3 now says, write down the balanced equation using molecular formulae for the complete combustion of compound F. Now, we know that when it comes to combustion, the general formula is just an alkane reacting with oxygen to produce carbon dioxide and water, right? Now, what is our alkane? Should obviously find the molecular formula of the alkane. This means we should expand this 3 times. So if we are expanding 3 times, we have 3 carbon atoms here, then plus the 1 here, plus this one here, that's 5. So that's C5, but then using our general formula CnH2n plus 2, we know that if we have 5 carbons, how many hydrogens should we have? 2 times 5, that's 10 plus 2, so we must have 12. Then like that. Reacting with O2 to give us CO2, then plus water. Now, You still remember chore method. Chore method, left-hand side, chore method, right-hand side. So in the left-hand side and then right-hand side. So what do we do? How many carbon atoms in the left-hand side? That's 5. How many carbon atoms on the right-hand side? Only 1. What integer value can I multiply to 1 so that I get 5? It's obviously 5. So just before carbon, I will put 5 there. And then let's go to the hydrogens. How many hydrogen atoms do I have on the left-hand side? 12. But then how many on the right-hand side? Only 2. What integer value can I multiply to 2 so that I get 12? Obviously, that's 6. Then we're going to multiply it by 6. And just before the hydrogen there, I put 6. And then how many oxygens do I have? Left-hand side, 2. And then right-hand side, let's calculate. That's 5 times 2, 10. And then 6 times 1 is 6. So 5, so 10 and 6, that's 16. Right. Now, what integer value can I multiply to oxygen so that I get 16? So that's obviously 8. So just before here on the left-hand side, I should just put 8. And then just like that, it is balanced. You can see that this gives us 16, this gives us 12, and then this gives us 5. Now, this is balanced. And that's how you were supposed to tackle this question, guys, for a total mark of 15. So please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. But and if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.